Everyone, this is Prerna Pradhan from Al Circle. I welcome you all to the webinar that we have held today. Before we start on with the webinar, let me introduce what Al Circle is. It is a global virtual aluminium ecosystem connecting the entire value chain from bauxite and alumina to primary metal, downstream products, and recycling. The platform delivers industry news, price data, business leads, company directories, and market intelligence tool that help stakeholders stay informed and connected. Under the ecosystem of Al Circle, we have three different platforms, that is Al News, Al Biz, and I'll learn a short intro about what these platforms are basically. So, Al News is the heart of our information related products. The key features include latest industry news, custom reports and market intelligence, interviews and e-magazines, price details and industry events, expert blogs and opinion pieces. Albiz is the online B2B marketplace connecting aluminium buyers and sellers. It is the priority listing and 360-degree market solution, the buyer-seller matchmaking basically. And Allearn is our newest initiative to create the world's largest online knowledge repository for aluminium. It basically aims to inspire and empower the next generation of industry leaders while also serving as a critical tool for those already shaping the future of aluminium. Today, we are here for the webinar on risk management strategies for projects across the aluminium ecosystem with the objective to provide insights on how to manage risk and ensure quality in all stages of aluminium plant commissioning with a focus on strategic decisions and practical frameworks. Our speaker is Mr. A.T. Mathew, advisor of Al Circle and aluminium industry and a project veteran. Before we start the webinar, I would like to announce some basic ground rules throughout the session. So we will take all the questions at the end of the presentation. All the attendees are to mute their systems during the presentation. If someone wants to talk, they need to raise their hand, unmute, and then speak. If attendees have any questions during the presentation, they can share them on the chat. We will address it during the Q&A session. It will be great if the attendees switch on their videos during the presentation so that making it a bit interactive with the speaker, and any sort of promotional activity will not be entertained. So hereby I conclude my introduction, and over to you, Mr. Mathew.
Good evening, ladies and gentlemen. It's my privilege to present a webinar on the risk management strategies for projects across the aluminium industry. Frankly, this has been the first time I have presented such a seminar, a small webinar for the veterans when the aluminium industry is going through a turmoil in different ways. And you can see aluminium prices spiraling, many people putting up new projects. So during uncertainty, there are more risks, and that's when people need to pull up their socks and see what are the best things to be done in order to carry out their projects. With this, a short agenda of my presentation is I'm focusing my presentation primarily on projects within the aluminium industry. What are the key risks in the early phases, which is design, procurement, supply delays, and quality of inputs? Then what is needed is from the client side, a creation of the core project team for planning and implementation. There needs to be a core project team under the promoter or the person who wants to carry out the project, carry out the planning and interpretation. Then comes to site selection, market study, logistics, etc. Pre-project activities, which is very critical, regulatory and environmental clearances, quality assurance framework, ensuring process, material and safety standards, selection of capable vendors, project implementation and cash flow. Cash flow is very important. Teamwork, clear and timely communications and decisions. These are the clear. This is a clear, I mean, sort of a roadmap for any project, be it in the aluminium industry or be it outside also as well. Now, coming to the various categories of aluminium industry projects, as under AL Circle, we cover the entire ambit of the aluminium industry. As I introduced, Prerna said, the type 1 is for the bauxite mines and alumina refinery, which is an upstream projects. Type 2 is the primary aluminium smelter projects, wherein we make from the liquid aluminium primarily from hot alumina. Then type 3, there are secondary aluminium processing units where you have a lot of recycling of scrap,
Mr.
recycling
Matthew,
of.
you can share your screen.
I am already sharing.
No, no, no.
Oh, sorry. Oh, it has restrained again. Is it coming? Can you see my screen? Not yet.
The presentation.
Yeah, I put screen share.
Yeah, your screen is shared, but we're not being able to see the slides.
Now?
Yes, 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 yes.
Yeah, can you see the screen now? Yeah, sorry.
Yes, yes.
So these are the 5 types of categories I have divided my presentation into, and I will discuss the risks in each of these 5 categories. So the first one is the upstream projects, whereas the first type of project in an aluminium cycle is the bauxite mines. So the major bauxite mining regions across the world are Guinea, Australia, Indonesia, India, Brazil, Jamaica, and Vietnam, because this bauxite is not available all over the world. So these are the primary countries where bauxite is mined. The key risk in a bauxite mining project is getting the environmental and forest clearances and getting the leasehold agreements. These are the two, getting the agreements with the governments at the national level or the state level, etc. Another key risk is to carry out a proper geological survey and estimate, because normally these bauxite mines are in many parts of the world are in deep jungle and forests, so access is a challenge, and taking number of samples. So it depends on how accurate your surveys are, and to know whether you have 5 million tons of bauxite or you have 10 million tons of bauxite, or what is the type of bauxite and what are the quality levels. So the more you do a pre survey, the better you have an idea of what is the quality of bauxite and how deep you have to be. Plus happens in many of these places, since it's a jungle where you have rehabilitation of people. So these are locational challenges, access. And since the bauxite mines are fairly deep in the jungle, mining and movement of the bauxite to the nearest refinery or to the nearest port also becomes a logistical challenge. So those are the part of the projects cost which the project team has to carry out, is basically, besides the technical thing of how many mining equipment you require, or whether most of the mines are open cast, how many earth moving equipment you require. The project team also needs to carry out the rehabilitation and resettlement of the people around, compensatory afforestation if it is needed to be done as per the environmental forest clearances, get a proper lease, I mean, agreement with the government. Basically, since most of the governments have a, whether you can, what is a period of at least 25 years or 30 years lease period for the bauxite mine, or 50 years. Is it a lease, or is it an acquisition of the land? So there are various types. So these needs to be taken up. Though these things take a long time than the actual project implementation at site, which can be only get delayed due to people issues around the people. So one of the key things of the project team when they come out at the site is to interact with the team around the site, around the project site, so that the project activities can go on without much trouble from the neighboring settlements. Coming to the next type of project, from bauxite, we go to the alumina refinery. The alumina refinery is basically a chemical refinery process wherein the bauxite from the mines is purified to make around 99.9% pure aluminium oxide. Basic. So here there are three types of refineries. One is there are very large refineries like 1 million tons and above, or there are smaller mid-sized refineries, alumina refineries between 100,000 to 500,000, smaller sized refineries are capacity. Basically, this the size depends on the capital expenditure plan of the company or the client. You can make a alumina refinery if your budget with about 5,000 crores or even with 500 crores of rupees or whatever the dollars or $1 million also you can make based on the size. The key challenge in the alumina refinery project is when you design the refinery, you must know really from where you are getting your bauxite. Based on the bauxite quality, you should design your alumina refinery, because when you the key assumptions are very clear, critical in designing an alumina refinery, because if you start assuming you get your bauxite from Australia and then you get bauxite from some other part of the world where the quality of the bauxite will not be the same, then your production will get delayed, your production will get, your impurities may be different, and then you get into trouble. So the operation team may start blaming the project that we are not getting the right quality, even at the licensor stage. So uh, this is very critical phase of the alumina refinery project, is to design the refinery based on the bauxite quality. So carry out what is called as a feed stage pre-project activities, which is a very critical part of alumina refinery and aluminium smelter, which is called front end engineering and design stage, wherein you have a core project team, wherein you make a project feasibility report with budgetary offers and time schedules, and make out a project funding options and the land requirement. And based on the feasibility report, you decide, because the top management only looks at the time and cost, whether it's 500 crores, 2 years, 3 years, what is your timeline. But making the assumptions are needed. What are the assumptions are to be clearly spelled out, so that tomorrow there are no questions asked. So in coming to refinery, you can, many large companies, what they do, how they execute projects is what they call is on an EPC basis, wherein they divide the refinery into 2 to 3 major areas and award large size contracts, maybe to 2 to 3 companies, so that the client has a small project team and he only has to deal with 2 to 3 lump sum contracts. This is a slightly expensive way of doing a project, but it ensures that if you are doing a large alumina refinery project, this ensures that you are dealing with big contractors, and there is a certain amount of comfort if a client or the bank dealing with it, because they are dealing with such large contractors. The other option is to break the project into several small bundles of orders, multiple packages, in which case the client will need a larger project team and he will have to do the interface between the contractors. Here the cost of the project will be less, definitely, but then you'll have to have your own project team. So you may have a pipeline contractor, you may have a compressor contractor, you may have a separate contractor for civil work, some for mechanical erection, electrical, etc. And then the integration is dependent on the project owned client's team, or you can also source some team. But That's a very critical thing, and it depends on the size. This can be more suitable, perhaps, for mid-size refineries, wherein the capital expenditure is not so high. The realistic timelines for concept to commissioning is 3 to 5 years, as I see in the current days. The, the, One of the major challenges in alumina production these days, which has always been there, is bauxite residue. It's getting more and more uh, relevant in the current days, where environment and sustainability is getting more prominence. This is a byproduct generated during production of alumina. Almost on an average, 1.25 to 1.5 tons of red mud is generated for 1 ton of alumina produced. And this is all, earlier these were kept as a landfill. Now this land is a big challenge. Getting land for storing red mud is a challenge. So red mud utilization is coming to be a big activity which is being practiced by most of the big aluminium producers. So there are many applications to reutilize the red mud. To know more about red mud, a scan code from Alcircle is there. We can go into detail. Coming to primary aluminium smelters, wherein the aluminium oxide is oxidized to make a hot metal, liquid aluminium, using electrolysis. As most of you be knowing, this is a energy intensive process and requires continuous 24/7 power. So all around the world, aluminium smelters are located close to reliable power source or captive power plants, or having a dedicated transmission line from the nearest hydroelectric or power station or the grid. So in the recent past, there have been only, you're hearing about large smelters coming around which is in the capacity of 300,000 tons or more. But you can put up smelters of mid-size or smaller, between 100 to 200,000 tons, as is seen in the recent past in China. Many of the smelters have been smaller and mid-sized as well. Here also, as in the case of the alumina refinery, the feed stage is very critical, which I say is which will reduce the risks in both alumina and aluminium. The feed stage involves the pre-project activities, wherein you decide the land to be acquired, selection of a core project team, which is the first thing, as we mentioned, carry out making a project feasibility report with budgetary offers and time schedules, and funding options based on that, seeing, because ultimately the challenge is to get a realistic time and cost estimate, and not just make the IRR attractive, not cut down and make the IRR attractive. So here also the project execution philosophy, as in the case of an alumina refinery, can be based on an EPC basis, wherein 3 to 5 large size lump sum contracts are given, and when the smelter is broken up into 4 or 5 packages, or you can have multiple packages, which is the conventional form of wherein you have a large engineering team consultant or an in-house project team. Realistic timelines for concept to commissioning and execution may be between 3 to 5 years without the power plant. In some countries, like in Middle East and in India, the aluminium smelter project goes parallel along with the power project as well. But that's a call the client has to take depending on where the location of the aluminium smelter is. In some aluminium smelters, they also try to outsource the anodes, because for every ton of aluminium produced, we need about half a ton of carbon anodes. And most of the large aluminium smelters do have their own captive anode production facility, which is around 40% of the total capital cost of the project. So one of the ways is to outsource production of anodes. There are independent anode producers who can supply anodes to feed the aluminium smelter, but this will increase your operating cost in the short term, but it will reduce your capital cost in the initial terms. The key challenges, as in the alumina refinery, are environmental clearances, access to steady raw material supply, and a dedicated power supply. These are the key challenges now facing aluminum smelters. Coming to the third type of aluminum processing, which is getting more relevant and more popular all over the world, is the secondary aluminum processing unit. Since it's more than 150 years since aluminum is being produced in the world through Hall Héroult process, there's a lot of aluminum being recycled, largely in the West. So aluminum is infinitely recyclable. So there are a lot of recycling units which wherein the capital cost is nearly 1/10 or 1/5 of the aluminum smelter. So uh, many of the automobile units or two-wheeler units have dedicated scrap recycling units for their aluminum castings and components, where it's a clutch, this thing. So they have good quality furnaces and good quality molds where they do sand castings or die castings and all. And this is a big uh, industry for setting up secondary aluminum processing units. This could be in the small industry level. It has gone up to medium industry, and some of them are fairly large with units located across many automobile ancillary units. This is a very popular way. Even in the large secondary aluminum units also feed the many of the downstream producers. There are many large scrap recycling units. So here the land requirement, the environmental risks are comparatively less as compared to an aluminum smelter or an alumina refinery. But the key challenge in these type of projects are uh, location challenges, because you need to have a source of scrap. It is better to have some of these secondary aluminum units close to where the scrap is being imported. Supporting it's near the port, it should not be too far from the port. And then you need uh, access to the port, and then safety also. Then another thing is the fuel for melting. Most of these aluminum smelters, I mean secondary aluminum plants, needs a good source of fuel, efficient source of fuel to melt the scrap. So most of them use either gas or furnace oil. Gas is more preferred because it's less environmentally, uh, has a less environmental impact. Now, for secondary aluminum processing units, the risks are equipment selection and layout for the plant and material flow should be very clearly laid out. What the layout is very critical because you will have a lot of material movement within the flow. It's a lot of material going out of the flow. The flow of the layout of the plant is so critical, then it can make the plant efficient during the operational stage. So that is one thing to be designed, kept in mind by the project team of a secondary aluminum processing plant. And also the equipment are standard. There are many companies all around the world, be it from China, Europe, USA, India, making these equipment. Of course, various levels of quality, but the layout and the scrap handling facility is the key thing, as I say, in the risks involved, and also the working capital needed for the hand sourcing the scrap during the operational stage. One of the major challenges in aluminum casting, so both the primary aluminum smelter where hot metal is produced, and in secondary aluminum smelters where hot metal is produced from scrap. When the melting takes place, dross is generated. Dross is a hazardous waste. It is an unavoidable byproduct of aluminum casting and melting operations. It leads to direct metal loss between 2 to 3% sometimes, or less than 1%. And it's a major headache for the secondary and primary aluminum smelters. Minimizing dross generation is another challenge the aluminum industry faces. Maximizing the recovery of aluminum, and what do you do with the dross? How do you reprocess it? To know more about aluminum dross, please check with Al Circle on this. Coming to the aluminum downstream units. The major utilization of hot metal aluminum is used as flat rolled products as sheet. Aluminum sheets and plates are basically rolled to be a final size of 0.15 to 0.25 mm thickness. The applications are, there are plenty of applications across the world: cookware, aircraft, bus body, train body, everything. So wherever aluminum is used, aluminum plates are used for various applications. So there are two major ways of routes for making flat roll products. One is the hot rolling route, and second is the concast route, wherein continuous casting. Hot rolling option is the higher capex option. It has a longer gestation period, but the hot rolling option is, it's similar to what in steel plants, where you have a 4 high mill or a 2 high mill to roll the thick aluminum sheets into by using a hot mill, and then subsequently there's a cold rolling mill. In the concast route, it's less capital intensive, but then the range of alloys, the range of widths and thicknesses the hot mill provides is less than in a concast, but the cost option is less. So in downstream units, the key risks are envisaged are for you, the client should know, the project proponent should know what type of product the rolling mill is planned to feed. If you are planning to produce cookware, then your configuration, the sizing of the hot rolling and the cold rolling and the balancing equipment is X. If it is for aircraft or truck body or for foil, then it is Y. So the type of mill and the type of the ancillary equipment, annealing equipment, heat treatment equipment will depend basically on the product, end product. And end product is decided by the sales and marketing team of the downstream thing. So the project team has to closely coordinate with the sales and marketing team of the company to understand what their requirements are and then size the equipment, because otherwise it is not a commodity. From downstream onwards, you are not in a commodity business, you are in a customer centric business. So based on the customer requirements, you will have to make the decide on the finishing equipment, decide on the heat treatment equipment, etc., packaging equipment, etc. So the downstream capex will be based, decided on the this thing. The hot mill, cold mill may be there, the crane may be there, but the other equipment will also add up, and the capex will be based on such on a total project cost. So this is a very critical thing for the project team to in a downstream aluminum unit. The second type of popular downstream aluminum unit is called the extrusion. As you see a side of the extrusion, this is where the aluminum being softer than the steel, the round billet is heated to around just below the melting point of aluminum and extruded through a die. Extrusion process is a relatively lesser expensive process than aluminum rolling, and extrusion is widely used for buildings like doors, window sections, pipes, and many other sections. So there's a huge demand for extrusions in the transport sector also, for bus body, truck bodies, etc., heat sinks. So the extrusion in the extrusion plant, the key equipment to be selected again with the marketing team is the size of the extrusion press, based on what type of extruded products you want to make for the market and what type of billets you will source. So the billets can be from 6-inch diameter to 24-inch diameter. These are the aluminum billets available. Where will you get it from? So based on the extrusion press, you first select that this is what the market you want. Then you decide the rest of the equipment. Defining equipment specification based on the range and selection, so you can make an extrusion plant with a very low cost, maybe less than 100 crores to maybe even to 500 crores or even 1000 crores, depending on the end user and the range of aluminum extrusions you want to buy and the type of alloys you want to buy. So that's very critical to decide first the extrusion press or the rolling mill, which is a key equipment in the downstream unit. First decide on that, as I say, and once that is decided and it is approved by the top management, and then you can decide on the remaining on ancillary equipment. That is the key thing to do. In the finishing and handling equipment, utilities, infrastructure can be added subsequently. Land requirement, as you see in the downstream aluminum, is comparatively less critical as compared to upstream. It is suggested that many of these downstream projects, the location is kept closer to the customers, wherein the aluminum is sheet or the extrusion is used to the marketplace, as I said. Unlike in the refinery or the aluminum smelter, which may be a little away from urban areas because they are kept close to power plants or kept close to the bauxite mines. Flat rolled and extruded products are customer specific, not commodities. And also, you don't need to keep them in go downs for too long. You can, you know, produce and even sell it immediately. So if it is closer to the customer, your working capital is less. Key equipment selection is critical. There's a level of automation incorporated, safety interlocks, gauge control, etc. Because, as you said, the customer demands are more here in the downstream projects. So, a lot of uh, close customer interface is there, wherein you have to take their loop and then gauge it up. Environmental hygiene in the plant is critical for certain critical plates and extrusions, especially in some depending on the plant is located in high humidity areas or very rainy areas, so or dusty areas. You need to take into consideration the HVAC requirements. Project timelines and financials are based on several criteria, basically around 18 months onwards. In downstream projects, you can achieve mechanical completion to the first coil production or the first extrusion production, but the full production stabilization would take much more time. We should keep when making the financials because when as you grow, the quality requirements are stringent in most cases. So when you build up the quality, it takes time for the equipment to fine tune the equipment. Many of these equipment, so you can make a coil, but it's not that the third day or the third week you can get reach full production level. Production level will take some time. So when the project team should, when they calculate the returns, they should keep in mind that production will take some time to stabilize, and there should be a hand holding between the project team and the operation and maintenance team during this period. Important to have. The fifth type of projects, which is quite popular these days, is the upgrades and modernization. What we call is capacity creep, brownfield projects. Basically, a lot of the existing plants, we need to upgrade them to reduce operating costs, to meet environmental norms, or to even meet customer requirements. There are increase in volumes in production to meet, or additional facilities to improve product mix, or energy reduction projects involving large capital expenditure. These are not maintenance type of projects. I'm saying large projects. The benefits of these upgrade and modernization projects is that there's lower capital expenditure rather than compared to a greenfield. You are having the existing land. You only need the incremental infrastructure, and there's already a operating team there, and you already have preferred option for aluminium companies as compared to lower timelines. But the challenges in the brownfield is you are to work along with the operating plant, integrating some of the new equipment with the older equipment. Sometimes the data for the old equipment is not fully clear, and then getting safety problems when you are dismantling some of the old equipment. And it doesn't, for the engineering, at the engineering phase there's more headaches involved, so sometimes engineering and consultants and contracts are reluctant to get into such upgrades, and you have to depend more on your in-house engineering teams. Common factors for project management across the aluminium industry and elsewhere: de-risking projects. My from Based on my experience, My sincere thing is to set up a core project team for the project before starting the project, and carry out a pre-project activities. Don't decide that just saying that $3,000 a ton or $500 a ton, and then say 2 years startup. Based on the appoint some consultants and agencies for enabling works. It will cost barely 1 to 2% of your total project cost. Carry out some enabling works. If possible, do some front end engineering and design. Evaluate options and obtain feedback. Cost estimate based on budgetary quotes and preliminary engineering works. Don't just copy paste from the Google. That would be not good. For the specific work you carry out, land and site selection, provision for expansion, is it located in an industrial estate, soil investigation, and local governance matters. It's very critical. Sometimes you start the work and then there may be some roadblocks. Infrastructural support, access to main roads, rail, power, and water supply. These are very key things when you start a project. How will you move heavy equipment to reach the place? Whether the roads are sufficient, whether there's a railway line, how is the power supply to carry out your erection work? Is there regular water supply for your project team to while working? So these are to be worked out. Government approvals and clearances. At times, clearances take very much long time. So how long do we wait before start the project? Can we get conditional clearances? These days, it's better to wait for clearances. And how much detail, and when you ask for more details, they will ask for more time. So these are things. Then cutting scope, de-scoping due to cost overruns and delays. This is another area which the project manager faces, is that you start with a particular timeline and a budget. As the project progresses, there are certain cost overruns and delays. Then we are asked to keep it within the same budget and the time. Then what needs to be cut? The important. Can you see me now?
Yes, yes.
Did you see the slide earlier?
Yeah, yeah.
Yeah, sorry for the interruption. I think there was a few examples of currently the aluminum industry is seeing an upswing with the good prices. Many projects are coming up. Some of the projects coming all over the world. I have just outlined a few. The ELYSIS inert anode cells coming up in Canada, Nalco in India, Balco in India, Hindalco is in. Also, all the three aluminum companies in India are putting up expansion projects. In Middle East also, Alba is putting up, shutting down its old lines and upgrading its new 4 and 5 lines. So in aluminium and alumina, a lot of new projects. In the downstream, there are plenty. I've just highlighted a few. Novelis is putting up a new rolling mill and recycling plant in USA. Egypt Alum is putting up a wire rod mill in Egypt. TMIC, Saudi Arabia, is putting up a foil mill. So plenty of action. And of course, in the recycling area, secondly, there are hundreds, but I am not mentioning because the recycling is getting more and more popular and a lot of people are recycling. Thank you. With this, I will once again thank the Al Circle management for giving me an opportunity to present to you, and I will leave the board team for question and answer session now. Thank you once again for your patient hearing.
Yes, so we already have a question. This has come from Oyun. The question is, since bauxite quality affects smelter grade, like you can also read the question. It is in the Q&A box.
Yes, let me just
Yeah.
see.
Since bauxite quality affects smelter grade alumina in production stage, I would like to understand whether any standard smelter grade alumina is suitable for producing primary aluminium grades like P1020 and P0610, or whether a specific alumina quality with tighter impurity control is required to achieve higher purity metal. You can stop sharing your screen if you want.
Where do I see the chat session? I can see the
Yeah, yeah. In the Q&A box, there is a question.
no open questions.
In the Q&A box,
Hmm.
beside the share button.
Hmm. There are no questions. No Q. But I'll answer that since you answered. There are no bauxite is not directly used for making aluminium. Actually, alumina is used for making aluminium. So, depending on the quality of bauxite, alumina will have some impurities to that extent. So, what to that extent, your alumina quality will be affected. It's not the bauxite quality. The bauxite quality only affects the alumina quality, and the alumina to smelt aluminium, if the impurities are high, the impurities in aluminium will also be higher. So what there are each company has its own specifications for alumina. Smelter grade alumina is traded worldwide. These are available, and they are some companies blend alumina if they are short on alumina, if they don't have their own alumina requirements, they blend from good quality and not so good quality as well. Yeah. What is the question? What is the currently the aluminium industry doing to mitigate the high production of red mud? They are trying to find alternate uses of red mud. Some people are using it in the cement industry. Some people are using it for road construction. So in the China, I understand they are trying to extract some metals out of it. There are many mentioned, as I mentioned in the uh, slide, which you can refer to the Al Circle report. I can tell you how there are many answers. There's no symbol missing. Okay, there's a question of what is the shell. There is no standard size. You can
There's one more question. You can also verbally answer the
This is a
questions.
question related to technology licensor for smelter. Do licensors provide detail engineering inputs for carbon area as well? They normally provide basic engineering for the carbon area. Detail engineering for the anode baking furnace is provided by some of the licensors, but not for the equipment, because the equipment you can get. Yeah, there's a from what would be the main incentives for a primary aluminum smelter to expand to a secondary aluminum processing unit, aluminum recycling? What would also be the main risks and challenges in doing so? The main incentives for an aluminum smelter to expand to a secondary aluminum processing unit is you're already handling aluminum. So if you're cast house, if you add one furnace or you can add some handling equipment, you can use the same casting equipment to, if you have a wire rod mill or if you have a slab casting unit or you have a billet casting unit, you can supplement your hot metal with secondary aluminum to make more billets or makes more slabs. So that's the biggest advantage for an aluminum smelter to expand to make secondary aluminum. So it's a right thing to do if you have space. The only thing is you should have some space to store the scrap and reprocess the scrap, because handling scrap is always a risk depending on coming from various places. Segregating the impurities, that's also the point. I hope I got your answer, Mr. Haryanto. Coming to, usually the smelters are AC or DC operated, DC operated. So we get the power from the power plant or the power grid in AC, and then it's converted to DC using rectifiers. Thank you. Okay, somebody is asking me what is the LME target for 2026-27. That's not in the scope of risk management. There are too many other
There is one more question before that. What is currently the aluminium industry doing to mitigate the right production of red
high
mud?
production of red mud. No, what they are trying to do is trying to find alternate uses for red mud. As I mentioned in my presentation, there are many uses for red mud. The aluminium industry and research institutes are collaborating all across the world. In China, there are research institutes. In the Europe, there are institutes. If you Google, and so depending on the applications. In India, they are using it in cement plants. So there are many applications depending on the country specific. If there is a lot of cement plants, then you can use it there. If there is a lot of road construction, you can use it there. So it depends on which country the alumina refinery is. What are the best technologies for treatment of aluminium slag or dross? There are many good technologies available around the world, in the Western world, the China, etc. Basically, what we do is try to from the aluminium dross, we try to recover the aluminium and use the aluminium back in the production process and reduce the quantity of dross, and also try to reduce the quantity, so that the nuisance value is reduced to the minimum. There are many companies supplying these aluminum dross treatment techniques. Some companies also outsource the dross. They give it to a third party who reprocess the dross and give back the aluminum and do that. That is also an option nowadays, so that you don't have to do it in house. This is also an option. I hope I have answered your question, Mr. Dias.
Okay. I would like to announce that to all the participants, we would be sharing the presentation, as well as we will be also sharing the recording of today's webinar. Along with that, we would be rolling out a feedback form, which would help us a lot in arranging future webinars on important topics from the industry. So, is there any other question? Okay, so there is a question in the box. What are, I will just read it out. What are the top risk categories you see in aluminium plant commissioning?
Top risk, which when you mean aluminium plant commissioning, do you mean an aluminium smelter or an alumina refinery or a aluminium rolling mill? I mean, can
This
you
is
be more
regarding
specific?
smelter. Smelter.
Smelter. As I mentioned in my presentation, the top aluminium smelter currently is the power supply. One is what aluminum power supply, steady access to steady supply of power is the key challenge, because putting up a plant is important, but getting steady power supply to the aluminum smelter is also even bigger challenge. Okay, there's another with anodes accounting for nearly 40% of total smelter cost. Even a 1% gain in anode density or current efficiency can save a smelter millions annually. Yes, very correct. As 20 million tons of new capacity comes online in Asia and the Middle East through 2026, how the anode companies positioning its technology to be high-end efficiency standards. So there are two ways to on the part. One is the technology. One is the uh, operations and how you cover your anodes in the pot lines. So yes, good and anode density is basic. There are two aspects. The anode plant manager in the operational phase has to get good quality raw materials and has to maintain his plant well. Most of the carbon plants are quite maintenance intensive because there are a lot of crushing, grinding, mechanical operations there. So timely maintenance, timely is a very important thing. So traditionally, the anode plants are oversized compared to the aluminum smelter. If the gap is less, then this sort of things happen, and then you have a problem on this. So most of the Western plants, they do have good quality standards. This thing, it's important thing in the maintenance operational phase how the operation team uh, uh, abides by the standard operating practices of the technology companies, anode companies. What do you see from Satyam? What do you see as the biggest structural risk for FRP players in the next 3 to 5 years? Raw material volatility, overcapacity, or trade barriers? FRP, when you say, do you mean flat roll products in the three: raw material volatility, overcapacity? Overcapacity, I don't see as a biggest structural risk, because most companies, when they design their rolling mill, they always build an overcapacity a little bit, 10 to 20%. You can't make it exactly. Trade barrier, if you, I think raw material volatility will be the biggest risk in my personal opinion, because trade barriers, if you have got a good product, I think none of these trade barriers is an interim thing, it will pass through. If you have a good quality product, people are prepared to pay the price for it, because FRP, if you have good quality and if you have and you earn a name, it should be done. Thank you, Satyam.
I see there are no more questions. So we can end this session.
Yeah.
Okay. So thank you all for joining. Thank you, Mr. Mathew, for this insightful webinar. Thank you so much.
Thank you very much again to all the attendees who came today to attend the webinar. Thank you once again, Prerna and Al Circle team, for hosting the webinar. Good night.
Good night. Bye.